is that the points on a line segment can be placed in a one-to-one relationship with real numbers. Basically, that just means that line segments can be measured. See, that's why I said these are kind of sometimes like, okay, duh, I can measure that, right? So the segment addition postulate comes from that, and that one says that if A, B, and C are collinear, okay, so A, B, and C are points and they're on a line, and point B is between A and C, okay. Well, point B is between A and C if and only if AB plus BC equals AC. So if AB plus BC equals AC, then that means B is between them. The picture would look like this. You'd have a line segment here and here. You'd have some point there. This would be AB, because that's A and B. And then this would be BC, and that's C. And then when you add them together, you'll get AC. Fancy way to say the two parts add up to make the whole thing.
So we already know this.
Mm-hmm. Using our segment addition postulate, we're going to prove that if CE is congruent to FE and ED is congruent to EG, then CD is congruent to FG. So we've got our if and thens, right? So that makes these two statements our given statements. I've listed them as given. And this is my proof statement. So step one is I'm going to label the picture. CE is congruent to FE. Okay. ED is congruent to EG. Okay, so I have this piece is the same size as that piece, and this piece is the same size as this piece. Right? I'm trying to prove that this whole length here will be the same as this whole length here. So in order to do that, I'm going to make my T-chart. And I will have statements on the left and reasons on the right. And my first statements are always given. Okay. If you want to save space, you don't have to write those as two separate lines. We could do it this way. Okay. As well. Okay, so you can put the givens in one line if they'll fit, or you can do separate lines for each given. It's up to you. I'm going to do this to save space. My next thing I want to look at, what does it mean to be congruent? They're equal, right? So I'm going to take those little segment pieces off the top, and now I'm talking about the length. So the pieces themselves are congruent. That makes the lengths equal. That's the definition of congruent. Okay. Well, if I want to go from these pieces to the whole thing, what do I need to do with the pieces? Add them together. So CE plus ED is going to equal CD. And then FE plus EG is going to equal FG. And for both of those is the segment addition postulate. So you could just say segment addition. Okay, so I've added the pieces together to get the whole. Now if I have two little pieces that add up to a big piece, and then I have two more little pieces that add up to a big piece, and the two little pieces were the same, can't I say that if CE is the same as FE, so I could take FE, and ED is the same as EG, so I could do EG, and won't it also equal CD? Like, because it'll be the lengths, right? So this length and this length are the same, so I can interchange them. And these two lengths are the same, so I could interchange them. So that's substitution. And now I have this equals CD, and I have this equals CD, but I also have this equals FG. Does that make sense? So I can do another substitution and say that FG is equal to CD from substitution. And if they're equal, they're congruent.
You can do this in any order.
What matters on the order is if I've been told congruent, I have to say that means equal before I can start using equal signs. So congruent means equal, then I can start adding in, like this part can be in a different order, but these parts need to kind of be in this order.
Oh, okay.
Does that make sense?
Yeah.
Okay. Always given first. And then if JL is congruent to KM, that means JL equals KM. That's the
Division?
yeah, so we went from congruent to equal, so that's definition of congruent. Okay. JK plus KL equals what? So I take JK and KL. Oh, I didn't mark my givens. JL, whoops. JL is congruent to KM. Those are the same length. Okay, what does JK plus KL equal? JK, yeah, JL.
How does it equal J?
JK plus KL gives you JL. The one piece plus the other piece gives you the big section. So I'll put more dots. Maybe that'll help. Okay. And then KL plus LM equals,
JK?
yeah, we're going from K to L and then L to M. So we start here and go here,
So it equals
KM. Okay, and that's going to be segment addition. JK plus KL is equal to KL plus LM because JL equaled KM. So I took this one out and put this in, and took this one out and put that in. So that's substitution. And then I can take, I'm trying to get to just get JK. I'm trying to get here and here, just those two things. So the way to do that is to take out this guy. So I subtract KL from both sides and put it in purple. Okay, it does show up on your screen. So I took KL away from both sides. That's subtraction. And if I take KL away from this, I'm left with JK. And if I take KL away from this, I'm left with LM. That's the substitution. And equal means congruent. That's the definition of congruent. I have, guys, I'm given that x is the midpoint of sy, and z is the midpoint of yf. And I want to prove that xy is equal to y. Oh, sorry. Xy is equal to yz, so xy is equal to yz. And I want to prove that zf is equal to sx. So what I have, these two are congruent. That's been given. And this and this, these are midpoints. Okay, so I've labeled my given information. I'm going to cut off my little y there. But I have my statements. And I have reasons. And I'm going to start with my given. So all three of these are given. Okay. If x is the midpoint of sy, what does that tell me?
X and Y are equal, the same length.
Yeah, that these two pieces here are the same length. So I can say that sx is equal to xy. That's the midpoint theorem. And if I have that z is the midpoint of yf, that tells me the same thing over here, that fz and yz are the same length because of the midpoint theorem. Okay, so now I have all these pieces that are the same length. So this is the same length as this, and this is the same length as this, and these two are already the same length as each other. Right here, x, y, and y, z. And so if I take these out, can't I say that these are the same? Okay, so I should have put in zf instead of fz because that's the way it was written in the proof. Okay, right? Because x, y, and y, z are already the same length, correct? Because we were told that here. And if these are the same length as those, and those are the same length as each other, aren't these the same length as each other?
Yeah.
And that's substitution. And then if they're the same length as each other, that makes them congruent because that's the definition of congruent.